A very common question that beginners in optics have is, if a single lens, like this, can form an image, then why is it that professional photographic lenses have so many lenses? Like this. One, two, three, four, five, six, seven. Seven lenses, seven elements, but okay, we'll just call them lenses. All right, so let's shed some light onto this problem. Pun unintended. Actually, how do you know when you do not intend a pun? Maybe I intended it. Okay, you know what? I intend all my puns. Okay, so anyway, um, let's go a little bit back in time. Before lenses were invented, people knew that if you cut a hole through a barrier, like this wall here, and you pointed the barrier or the hole to a scene, like this object, this tree, then if you put a screen behind the hole, there's an image of the scene. And it's inverted because of the geometry of rays. Like if you take a ray from the top here and trace it all the way through the hole down to here, and you take a ray from the bottom, trace it all the way through here, then the image is just flipped, right? Okay, so and then people realized that the bigger the hole, the brighter the image, but the blurrier the image. And that's because every point on the object is a source of rays, and the image comprises many, many spots of light that come from the hole. So a collection of small spots gives you a sharp image. A collection of big spots gives you a blurred image, right? So small holes resulted in sharp but dim images because, there's less light going through a smaller hole. So when lens designers or when scientists or when people discovered the lens, what they did was they said, okay, something like this, right? It's not like accurate history, but something like this. Roughly speaking, they said, okay, let's open up a hole so it's big to let more light through, but we'll fill the hole with material called glass, right? And if you shape the glass just right, then all the rays from a point will be focused, converges into a small spot, forming a bright, sharp image. All right, and how do you know that how do you know what kind of curvature, what kind of shape the lens must take? It usually is like convex, right? Convex or plano convex, something like that. How do you know that? It's because there's a principle in lens design where if all the rays from a single point reaches a point in the image at the same time, then the image will be sharp. That's the principle. So think of it this way. Every ray in this space right here is traveling at the same speed. So the ray traveling at the center is traveling a shorter distance. The ray traveling at the edge is traveling over a larger distance. So how do you get all the rays to get to the same position in the image plane at the same time? Well, you slow down the light that is traveling at the center. You create thicker material there. It's like throwing a lot of mud for a racer traveling at some speed to the target. And for the racer that's traveling at the same speed but over a longer distance, you throw less mud there, right? So you take away some material at the edge of the glass, you put more material at the center, and if you do that across the whole glass surface, you get this shape, which is a lens, a convex shape. But that's not all, right? It turns out that lens designers also discovered that uh, the information about time, how much time it takes for rays to travel in space, is contained in the amount of blur in the image, the spot, how large the spot of light is that you focus to in the image. And it turns out that each lens you add adds a certain amount of blur, but the addition is not completely positive. It's additive and subtractive. You can take lenses, if you shape them the right way, if you space them out the right way, each lens can add or subtract each other's blurriness and make the blur come down to zero or near zero. And that is why a professional photographic lens has multiple elements, or it's called a multi-element lens. And I hope that helps. Bye bye.